This video is on sample space, and we've actually looked at some of this before, flipping a coin and whatnot. So let's take a look at what a sample space entails. A school uniform requires all students to choose from a blue, a green, or a white polo, and either khaki or navy shorts. A polo is randomly selected from a drawer with one of each color. Record the options in the list below. So we've got a blue polo, a green polo, and a white polo. Okay. A pair of shorts are randomly selected from a drawer with one of each color. Record the options in the list below. So we have khaki, and we have navy. And then we have khaki here, and navy, khaki, and navy. So there are our total outcomes are right here. All right. So we use the tree diagram below to show the two events and the total possible outcomes when selecting a polo and a pair of shorts. So we have the list the total possible when selecting the polo and a pair of shorts. Here we've got a blue with a khaki and a navy, a green with a khaki and a navy, and a white with a khaki and navy. So how many possible outcomes when selecting a polo shirt and a pair of shorts? 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. And the way you'd look at that, you'd have blue and khaki, that's 1. Blue and navy's 2. Green and khaki, green and navy, that's 4. White and khaki, and white and navy, and that's 6. Use the tree diagram or list to determine the probability of selecting a blue polo with khaki shorts. So the possibility of selecting a blue polo with khaki shorts is 1 out of 6. Because there's only one blue and khaki. Okay. The sample space describes all possible outcomes of events. The sample space can be displayed, using a list or tree diagram to determine the probability of simple or compound events. Compounds means more than one. Use your understanding of lists and tree diagrams to represent the sample space. A fair coin is tossed 3 times. What are the possible outcomes? Okay, we can flip a coin and we're going to get either heads or tails. That's one flip. And if we flip this heads, we can get heads or tails. And if we flip this tails, we can get heads or tails. And that's our second flip. All right, our third flip, here is going to be heads or tails, and here is going to be heads or tails. Because when you flip the tails, you're either going to get heads or tails. Same here for heads or tails, and here for heads or tails. Okay, so there's our sample list. How many total outcomes are possible? 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. All right, number 2. For breakfast, Jamie can choose from cereal, eggs, or a muffin. She also can drink coffee, orange juice, or milk. What are all the possible outcomes, and how many total outcomes are they? So let's do another tree diagram. We've got cereal, we've got eggs, and we've got a muffin. She also can drink orange juice or milk. Coffee, orange juice, or milk. So here we need coffee, orange juice, milk, coffee, orange juice, and milk. And with the English, with the muffin, I said English because that's what I get at Biscuitville. Coffee, OJ, and milk. So how many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible outcomes. And you can do that as a list too. Amanda will roll a number cube and flip a coin. If Amanda rolls the number cube once and flips the coin once, then what are the possible outcomes in which a number cube lands on an odd number? So let's do a list of this one. The number cube 1 can land on heads, and number 1 it can land on tails if it's doing an odd number. Okay, then we've got 3 that can land on heads, and 3 that can land on tails. And then we have 5 that can land on heads, and 5 that can land on tails. So then what are and how many possible outcomes are they? So it doesn't ask for that, but how many are they? 1, 2, 3, 4, 5, 6. 6 possible outcomes. Number 4. At registration, a student can select from Spanish or German class, as well as art, music, or theater. Create a tree diagram to represent the possible outcomes. All right, so we have Spanish. So they can choose Spanish or German as one, and then they have to choose art, music, or theater. And the same if they choose German. They can choose art, music, or theater. What is the probability that a random selected student has enrolled in Spanish and theater? So one, we need total outcomes. We got 1, 2, 3, 4, 5, 6. So we have 6 possible outcomes. So what is the probability that a selected student will choose Spanish and enroll in theater? So that's only 1, right? So it's going to be 1 out of 6. How would adding in a French class change the tree diagram above? So if we added French over here with the 3, we would add 3 more outcomes, right? So that would make 9 possible. It would go from 6 to 9 outcomes. How would it change and then justify your thinking? Well, if we just added, we added French. This is just hypothetically speaking. And then we had art, music, and theater. And then we would add 1, 2, 3 more outcomes to it. Jenny rolls a number cube and spins a spinner shown below. The tree diagram below shows the possible outcomes. Complete the tree diagram to represent all possible outcomes in which she rolls a number greater than 3. So that would be 4. So 4 is greater than 3. And then we just, the colors here, we got red, blue, green, and pink. Because 3, 2, and 1 are all equal to or less than 3. So that would be that. Any help on making tree diagrams or lists, just let me know.